Welcome to Still Science Lab. Tonight, we are going to tear down the comforting illusions that protect your everyday sanity and explore the terrifying mathematical truth of why physics proves we are blind to 17 layers of reality. Everything you were taught about how reality works, the atoms, the forces, the laws of physics, all of it is built on a foundation that physicists themselves cannot explain. Not the edges, the foundation. And the alarming part is not that one thing is missing. It is that when you pull at any layer of reality, any single thing physics claims to understand, you find another layer underneath that nobody has ever explained. 17 of them confirmed by experiment, open for decades, some for 100 years. What is matter actually made of at the deepest level? Why does time only move one way? Does anything exist when nobody is looking at it? Is the universe we see actually real, or a projection of something we cannot access? These are not philosophical questions. Physicists have run the experiments, the data is in, and the answers are genuinely alarming. Tonight, we begin by looking at the absolute baseline of our cosmic ignorance. Start with 4%, that is the number. 4% of the universe is described by the best physics we have. The floor you are standing on, the air you are breathing, the light you are seeing, all of it is part of the 4%. The rest sits outside our framework, acknowledged and uncharacterized. We know it is there because of what it does, but we do not know what it is. Something is holding the universe together that we cannot see, cannot touch, and after 90 years of trying, cannot find. The first person who noticed this was laughed out of the room. His name was Fritz Zwicky. In 1933, he was studying a massive collection of galaxies called the Coma Cluster, roughly 1,000 galaxies pulled together by gravity into one enormous system. He wanted to know how fast they were moving, so he measured, and when the numbers came back, they did not make sense. The galaxies at the edges of the cluster were moving so fast that gravity alone should not be able to hold them in. Based on all the visible mass, every star, every gas cloud it passed, everything the telescopes could pick up, the cluster should have been flying apart millions of years ago, but it was not flying apart. It was perfectly stable. Zwicky proposed something radical. He said there must be matter out there that produces gravity, but produces no light. Matter that is invisible by definition. He called it dark matter. His colleagues ignored him for 4 decades. Then, in the 1970s, an astronomer named Vera Rubin measured the rotation curves of individual galaxies and found the exact same problem. Galaxies were spinning in ways that only made sense if most of their mass was invisible. The math was unambiguous. Something was there, something enormous, something that makes up about 27% of everything in the universe. 27% is not a rounding error. It is not a footnote. It is more than 6 times the mass of everything we have ever seen, touched, built a telescope to look at, or written a physics equation to describe. 6 times. What does it mean for a science to officially include something in its model that it cannot describe? And if the answer to that question does not sit comfortably with you, it should not. But what if the problem is not just that we cannot see it, but that every tool we have built to find it has come back empty? The search for dark matter is one of the most expensive, most coordinated, and most sustained experimental efforts in the history of science, and it has found nothing. The detectors built to find dark matter are not simple devices. Xenon 1T, built under a mountain in Italy, used 10 tons of liquid xenon cooled to -95 degrees and surrounded by water shielding to block every known particle that might create false signals. Lux in South Dakota sat nearly a mile underground inside an old gold mine. Panda X in China went even deeper. The entire point of burying these machines is to eliminate noise, to create the quietest possible environment so that if a dark matter particle passes through and nudges a single atom, the detector catches it. They have been running for decades combined, not one confirmed signal. Here is the question that physicists do not always phrase directly. What does 40 years of silence tell us? There are three possibilities, and none of them are comfortable. The first is that dark matter exists, but interacts with normal matter so weakly that even our most sensitive detectors cannot catch it. The second is that dark matter exists, but is not made of the kind of particle we have been looking for, meaning decades of experiments were built on the wrong assumption. The third is something else entirely, something that most physicists are reluctant to say in public. Maybe the way we model gravity is wrong, and dark matter is not a thing at all, but a sign that our understanding of gravity breaks down at galactic scales. I find the third option the most unsettling, not because it is necessarily right, but because it means the problem might be inside the theory we are using to look, not outside in the universe we are looking at. A tool that cannot find what it is looking for is either broken or looking in the wrong place. After 40 years, we have not figured out which one it is. This brings us to something even larger, because dark matter is only 27% of the missing picture. In 1998, 3 teams of astronomers were doing something that sounded straightforward. They were measuring how fast the universe was expanding by looking at a specific type of exploding star, a type 1, a supernova, which always explodes with the same brightness, making it a reliable measuring stick across cosmic distances. The assumption going in was simple. The expansion of the universe started by the Big Bang should be slowing down because gravity pulls things together. It was not slowing down, it was speeding up. Saul Perlmutter, Brian Schmidt, and Adam Rees, working in competing groups, all got the same result independently. The universe is not just expanding, it is accelerating. Something is pushing everything apart, and that push is getting stronger over time. They called it dark energy. They won the Nobel Prize in 2011, and then physics ran into a wall. Because here is what the theory says dark energy should be. In quantum mechanics, empty space is not actually empty. It seethes with tiny fluctuations of energy, particles popping in and out of existence. Theoretically, all of that vacuum energy should contribute to the push that is accelerating the universe. When physicists calculated how much energy empty space should contain, they got a number. When they measured how much dark energy is actually out there, they got another number. The two numbers disagreed by a factor of 10 to the power of 120. Let that sit for a moment. 120 orders of magnitude. That is not a calculation error. That is not a rounding issue. That is the largest discrepancy between a theoretical prediction and an experimental measurement in the entire history of science by an almost incomprehensible margin. And yet the theory that produced this number, quantum field theory, is the same theory that predicts the magnetic moment of the electron to 12 decimal places. The same framework, wildly precise in one place, catastrophically wrong in another. Most physicists will tell you this is a puzzle waiting to be solved. I think it is something more specific than that. It is a signal that something is structurally wrong with how we are connecting our two best theories of reality. There is a darker layer here. In April 2024, a collaboration of scientists released the most detailed map of the universe ever constructed. 6 million galaxies, 11 billion years of cosmic history plotted with a precision that no previous survey had approached. The project was called DESI, the dark energy spectroscopic instrument. And what it found quietly demolished a model that had stood unchallenged for 25 years. The standard model of cosmology, called lambda CDM, treated dark energy as a constant, a fixed number, a permanent feature of space that does not change. This assumption sat at the core of every cosmological calculation made since the late 1990s. It was not a tentative hypothesis. It was the foundation. DESI's data suggests the foundation is wrong. The measurements indicate that dark energy is not constant. It changes over time. It behaves more like a dynamic field, something that evolves, than a fixed property of empty space. The statistical confidence of this result sits at 3.9 sigma, a strong hint built on 6 million galaxies and 11 billion years of data is not the kind of thing you dismiss over breakfast. What does it mean if dark energy changes? It means lambda CDM, the model we use to describe the large-scale structure of the entire universe, is at minimum incomplete and at maximum wrong in a fundamental way. Every prediction made using that model, every calculation of how the universe evolved and where it is going now, sits on uncertain ground. This is not an anomaly from a single experiment. This is the universe itself, measured across billions of light years and billions of years of time, telling us something does not fit. We built the most precise map of reality we have ever made, and the map is showing us that the territory is different from what we thought. Ask yourself what it means to lose your model of the entire universe in a single data set. The missing mass and the unexplainable acceleration are not distant theoretical problems. They are the immediate physical environment of our existence. The rest is present everywhere around you, in every cubic centimeter of space, in every galaxy you will never visit, threading through everything that has ever existed, and we have no idea what it is. Ask yourself what it means to live inside a reality that is mostly unknown. Ask yourself whether the silence around this fact is comfort or avoidance. We are entirely blind to 96% of our own existence, trapped in the thinnest, most superficial layer of a cosmos that refuses to explain itself. We navigate our existence fundamentally relying on the deeply ingrained biological intuition that reality is a seamless, unbroken continuum. When you pour water from a glass, it flows in a smooth, continuous stream. When you watch a pendulum swing, it traces a perfect, uninterrupted arc through the air. When you feel the warmth of a fire on your skin, you experience it as a steady, gradient wave of heat. Our sensory apparatus evolved to perceive the world as perfectly fluid, and for centuries, the entire grand architecture of classical physics was nothing more than a rigorous mathematical formalization of that exact biological bias. The equations written by Newton and Maxwell treated space, time, and energy as infinitely divisible, a smooth fabric without seams or tearing. This continuous model was so incredibly successful, so deeply intuitive, and so flawlessly predictive of the macroscopic world that physicists genuinely believed they had uncovered the final, absolute language of nature. But to understand how deep this goes, we have to step back from the cosmos and look at what happens when physics tries to measure something much smaller and finds that the act of measuring it changes everything. At the dawn of the 20th century, the flawless machinery of classical physics encountered a catastrophic, insurmountable glitch. The crisis did not emerge from the far reaches of the galaxy or the complex depths of the atom, but from something as mundane as the glow of a heated object. Classical physics said that any hot object, a furnace, a candle, a human body, should radiate infinite energy. The equations that had perfectly described the orbits of planets and the propagation of light suddenly turned against their creators. The mathematics dictated an absolute absurdity. Every object you have ever touched should, according to the physics of the time, be pumping limitless radiation into the universe. If the continuous equations were true, the simple act of striking a match should release enough high-frequency radiation to instantly incinerate the observer and permanently obliterate the surrounding environment. Obviously, nothing like that was happening. We were not being instantly vaporized by the infinite ultraviolet fury of a simple glowing ember. The physical reality was safe, stable, and finite, but the math kept insisting it should. The most sophisticated theoretical framework ever devised by human intelligence was mathematically demanding the immediate destruction of the universe. Into this agonizing contradiction stepped a reluctant physicist named Max Planck. Planck was a deeply conservative thinker, a man who profoundly revered the elegant, continuous laws of classical thermodynamics. Planck was not trying to change physics. He had absolutely no desire to revolutionize our understanding of the cosmos or to overthrow the established scientific order. He was trying to stop an equation from producing something insane. He stared at the terrifying mathematical divergence, the relentless progression toward infinity, and recognized that the only way to save the framework was to forcefully artificially amputate the infinite extreme. So, Planck added a patch. He introduced an arbitrary mathematical restriction, a completely unjustified rule that directly violated every classical instinct he possessed. He said, energy cannot flow continuously. Instead of treating energy as a smooth, infinitely divisible wave, he forced the equation to treat it as a granular substance. It has to move in tiny fixed chunks, little packets. He called them quanta. By artificially forcing the energy to be divided into these discrete, indivisible packets, he successfully prevented the equation from running away into infinite catastrophe. The math suddenly balanced. The prediction matched the safe, finite reality observed in the laboratory. But you must understand the psychological reality of what had just occurred. Planck did not experience a moment of profound, visionary enlightenment. He experienced a profound sense of intellectual defeat. He later said this was an act of desperation. He had committed mathematical heresy simply to make the numbers work. He did not believe the chunks were real. He viewed his own solution as nothing more than an ugly, temporary accounting trick, a convenient mathematical fiction that allowed the equations to accurately model the data without representing any actual physical truth about the underlying nature of reality. He thought he had found a trick to make the equation behave. He fully expected that a future generation of physicists would come along, discard his desperate, jagged patch, and restore the beautiful, continuous flow of energy to its rightful place at the center of physics. But the restoration never came. The terrifying reality of the situation slowly began to dawn on the scientific community over the following decades. The trick was real. Within 25 years, experiment after experiment confirmed it. As our instruments became vastly more sensitive, peering deeper into the subatomic void, they consistently encountered the exact same jagged, discontinuous behavior. Energy genuinely moves in packets. When an electron transitions between states in an atom, it does not move smoothly through the space in between. It instantaneously ceases to exist in one orbit and violently manifests in another, emitting exactly one indivisible quantum of light. There is no in-between. The continuous reality we perceive is a macroscopic hallucination, a smoothing over of a fundamentally pixelated, granular existence. The universe actually works that way at its smallest level. Planck's desperate fix was not a fix. It was not a temporary scaffolding holding up a broken classical theory. It was the first true glimpse of how nature is built. We have built an entire modern civilization upon this fragmented architecture. The semiconductor chips powering your devices, the lasers carrying global communications, the magnetic resonance imaging machines peering inside the human body. All of these trillion-dollar technologies explicitly rely on the relentless, uncompromising reality of the quantum leap. We industrialize the jaggedness of the universe. And here is the part that does not get said enough. The man who discovered quantum mechanics did not believe in quantum mechanics, the absolute foundational bedrock of modern physics, the theory that provides our most devastatingly accurate descriptions of matter and light, was birthed by a mind that completely rejected its ontological implications. He was right about the math and completely wrong about what the math meant. This historical reality forces us to confront a deeply paralyzing epistemological nightmare. We operate under the comforting delusion that scientific progress is a rational, deliberate uncovering of profound truths by visionary intellects who deeply comprehend the nature of their discoveries. We want to believe that when we write down a fundamental law of physics, we are transcribing the literal geometric blueprint of the cosmos. But the origin of quantum mechanics proves that human comprehension is utterly irrelevant to mathematical success. So ask yourself, if the person who wrote the equation did not understand what it was describing, what does that say about every equation being written right now? We are currently generating unfathomably complex mathematical frameworks, string theory, loop quantum gravity, holographic projections to explain the remaining mysteries of the universe. Physicists manipulate vast multidimensional geometries and balance intricate theoretical symmetries, confidently presenting these equations as the ultimate architecture of reality. But what if they are exactly like Planck? What if they are simply writing down blind, desperate patches to stop their models from collapsing into infinity? We measure the success of a theory by its ability to predict experimental outcomes. If the math balances and the detector clicks exactly when the math says it should, we proudly declare that we understand the universe. But predicting an outcome is vastly different from understanding the underlying machinery. We have successfully reverse-engineered the code, but we are completely blind to the intention of the programmer. Ask yourself how many of our current fixes are real and how many are just patches that happen to work. When we invent a concept like dark matter to stop our galaxies from flying apart on paper, or when we insert an arbitrary cosmological constant to balance the expansion of the universe, are we discovering new layers of reality? Or are we simply engaging in the exact same mathematical desperation that defined the birth of the quantum era? We are piling algorithms on top of algorithms, constructing a towering, precarious intellectual edifice built entirely out of successful mathematical tricks. And ask yourself whether there is actually a difference. If a desperate, arbitrary mathematical hack flawlessly predicts the behavior of the universe to 12 decimal places, does it matter that it was born from misunderstanding? Does the universe care about our philosophical discomfort? Perhaps the most terrifying revelation is not that our fundamental laws might be illusions, but that the universe itself might be nothing more than the sum total of these jagged, disconnected mathematical rules. Perhaps there is no deeper, elegant, continuous reality hiding beneath the floorboards. We are forced to reckon with the agonizing possibility that we are trapped inside a cosmos that operates exactly like a broken machine held together by duct tape and desperate algorithms. We exist entirely at the mercy of equations that blindly execute their commands in the dark, governed by laws authored by minds that did not believe them, describing a reality that fundamentally defies our need to comprehend it. We equate precision with truth. It is a deeply ingrained, almost biological, psychological defense mechanism that we use to protect ourselves from the chaotic, incomprehensible vastness of the cosmos. We desperately want to believe that if we can measure a phenomenon with enough decimal places, if we can predict its behavior with razor-sharp mathematical accuracy, we have somehow conquered it. We believe that precision strips the universe of its terrifying mystery and binds the raw, unfeeling forces of nature to our rational will. We look at our towering monuments of modern technology, our particle accelerators and our quantum arrays, and we feel a profound sense of absolute intellectual mastery. We assume that because our equations work, the fundamental philosophy underlying those equations must be a perfect geometric reflection of physical reality. But what if the most accurate tool in the history of science is built on something we have been deliberately not looking at too closely? The chilling reality is that the absolute pinnacle of human scientific achievement is not a monument to our profound understanding of the universe. It is a monument to our staggering ability to mathematically cheat. To understand the sheer paralyzing scale of this illusion, we must first look at the crowning achievement of theoretical physics. Here is the most accurate prediction in the history of science. Physicists calculated that a property of the electron, how it responds to a magnetic field, and the number they got matched the measured value to 12 decimal places. 12. This level of exactness is almost impossible for the human brain to intuitively visualize. If you were measuring the distance from New York to Los Angeles, that accuracy would put you within the width of a human hair. Physics did that. It is a triumph of human intellect that borders on the miraculous. A calculation so flawlessly aligned with the physical universe that it seems to prove, without a shadow of a doubt, that we have finally deciphered the ultimate source code of reality. We look at those 12 decimal places and we feel entirely, completely secure in our dominion over the subatomic realm. Now, here is the part that should bother you. The method that produced that number works by running into infinity and cancelling it out by hand. The absolute bedrock of our most precise science is hiding a catastrophic mathematical nightmare. When physicists attempt to calculate the properties of a particle, they cannot simply treat it as an isolated object floating in an empty void. A particle, like an electron, generates its own electromagnetic field, and in the relentless, unforgiving logic of quantum mechanics, the electron must constantly interact with the very field it creates. It emits and absorbs virtual photons in an endless, microscopic frenzy. But when you calculate how an electron interacts with its own field, the math produces infinite values, numbers that mean nothing. Infinity, in the context of a physics equation, is not just a very large number. It is a fatal pathology. It is the mathematics violently breaking down, screaming that the theory has failed, that the model has collapsed into absolute logical absurdity. An infinite mass or an infinite charge is a physical impossibility, a tear in the fabric of rational thought. Faced with an equation that was essentially self-destructing, the pioneers of quantum field theory did not abandon their framework. Instead, they invented a mathematically violent workaround. So, physicists developed a procedure. They subtract one infinity from another, extract a finite answer, and move on. They perform an algorithmic sleight of hand, mathematically amputating the infinite absurdities to artificially force the equation to yield a clean, usable number. It is a process formally known as renormalization, but stripping away the sophisticated academic terminology reveals a process that is fundamentally, deeply unsettling. You cannot mathematically subtract infinity from infinity and reliably get 12 decimal places of precision. It violates the deepest, most sacred rules of pure mathematics. Yet, in the realm of theoretical physics, they do it anyway. They blindly hack away at the catastrophic divergence until a beautiful, finite prediction emerges from the wreckage. The people who invented this procedure were not blind to the horror of what they had done. They did not celebrate this mathematical mutilation as a profound discovery of natural law. Richard Feynman, one of the people who built this method, called it sweeping things under the rug, his words. The man who built the tool described it as hiding something rather than solving it. Feynman, arguably one of the most brilliant and uncompromising theoretical minds of the 20th century, looked directly at the most successful physical theory ever devised by humanity and recognized it as a deeply sophisticated fraud. He understood that extracting a correct number through an unjustified mathematical trick is not science. It is engineering in the dark. So what is under the rug? What terrifying, incomprehensible reality are we deliberately ignoring because our math is too fragile to describe it? We have simply chosen to stop looking at the abyss because the abyss breaks our equations. This forces us into a deeply uncomfortable epistemological corner. We do not know we have the right answer. We have a procedure that produces it. We have built a remarkably efficient black box. We feed our questions into one end. The box performs a series of unjustified mathematical cancellations involving infinite absurdities, and the correct 12 decimal place answer flawlessly prints out the other side. We do not have a full understanding of why the procedure works. We are exactly like a primitive civilization that has discovered a highly advanced alien calculator. We have learned which buttons to press to get the food to drop from the dispenser, but we have absolutely no conception of the circuitry, the logic, or the physical laws operating inside the machine. We have divorced predictive utility from fundamental truth. We have accepted a universe that allows us to hack its localized outputs while violently forbidding us from reading its actual source code. And the true dread of this situation is not isolated to a single obscure calculation. It is systemic. It is the foundation of our entire physical worldview, and everything in modern physics, every particle experiment ever run, every calculation that predicted the behavior of matter sits on top of this method. The sprawling multi-billion-dollar infrastructure of the Large Hadron Collider, the medical technologies saving lives in our hospitals, the silicon processors driving our global digital networks, they are all perched precariously atop this exact same mathematical rug. We have built a towering, glittering empire of technology on a swamp of infinite contradictions. Ask yourself, what do you call a foundation that works perfectly and is not understood? Is it a science? Or is it merely a highly successful, mathematically formalized superstition? We are trusting our existence to a rulebook that we know is fundamentally broken, simply because the broken rules currently happen to be acting in our favor. We must violently confront the arrogance of our own scientific complacency. Ask yourself whether getting the right answer is the same thing as understanding why the answer is right. If a student cheats on an exam and perfectly copies the correct answers without comprehending a single underlying concept, we do not call that student a master of the subject. Yet, as a species, This is exactly what we are doing with the fundamental architecture of the cosmos. And ask yourself, what happens to everything built on top of this if we ever have to look under the rug and find something we cannot cancel out? What happens when our technological ambitions push us into a regime of physics where the trick stops working? What happens when the infinities refuse to be subtracted, when the rug is violently pulled away, and we are forced to stare directly into the incomprehensible, mathematically hostile machinery that actually runs the universe? Most physicists will tell you this is a solved problem, just technically messy. They will point to the 12 decimal places of precision as absolute proof that the underlying philosophy must be sound, ignoring the agonizing reality of how those decimal places were violently extracted. I think that is the most comfortable version of the story. It is a psychological shield, a way for the scientific establishment to sleep at night while resting upon a foundation of infinite mathematical sand. The less comfortable version is that we built the most precise science in history on a method its own architects admitted they could not fully explain. We are completely, terrifyingly blind. We are navigating the deepest, darkest waters of the cosmos, using a compass that is fundamentally broken, guided only by the terrifying fact that, purely by accident, it has not yet steered us into the rocks. We place an absolute, unquestioning faith in the mathematical narratives we construct to describe the universe, finding profound psychological comfort in the idea that our equations offer a continuous, unbroken chain of logical cause and effect. We believe that if we possess the correct formula, we can trace the unbroken lineage of a physical event from its inception to its conclusion, illuminating the dark mechanics of reality with the sterile light of human reason. But what if the problem goes deeper into the moment when physics actually happens and finds it has nothing to say? The most chilling realization in all of modern science is not that our equations occasionally fail at the extreme, inaccessible edges of the cosmos, but that they go completely, terrifyingly silent at the very center of our everyday existence. Physics cannot explain the moment when physics happens. Let that land. We possess a framework that perfectly describes the stage, flawlessly details the lighting, and meticulously catalogues the actors, but goes completely blind the exact millisecond the play actually begins. To understand the sheer, paralyzing depth of this abyss, you must look at how we interrogate the subatomic world. Every experiment in quantum mechanics ends the same way. You set up a system, you isolate a particle, you shield it from the chaotic thermal noise of the surrounding environment, and you mathematically map its potential. The math describes it as existing in multiple states simultaneously. It is not a single, solid object existing in a definite location. It is a sprawling, ghostly cloud of mathematical probability. The particle is here and there and everywhere the probability allows. In this isolated state, the universe is a symphony of overlapping, infinite potentials, governed by a piece of mathematics known as the Schrödinger equation. This equation is arguably one of the most beautiful, deterministic, and flawless conceptual tools ever forged by the human mind. It predicts exactly how that cloud of probabilities will smoothly undulate, shift, and evolve over time, like a ripple moving seamlessly across a dark, undisturbed ocean. It is an architecture of pure, unblemished logic. Then you measure it, and it is somewhere specific. One place, one outcome. The instant you open the box, the instant a detector clicks or a photon strikes a screen, the infinite, undulating ocean of overlapping realities violently vanishes. The wave of possibilities collapsed into a single fact. The ghostly superposition instantly snaps into a hard, unforgiving, concrete point of physical reality. But here is the catastrophic, universe-shattering problem at the heart of our most successful science. The Schrödinger equation, the equation that governs all of this, does not contain the moment when that collapse happens. There is no term for it, no variable that switches on when a measurement occurs. The equation describes the wave of possibilities evolving smoothly through time, and then reality produces one outcome, and the equation has nothing to say about how or why that transition occurs. The mathematics simply stop. The logic completely disintegrates. The transition from an abstract, mathematical probability into a tangible, physical reality is a mechanism that is entirely absent from the physics that supposedly governs it. We are forced to confront an existential nightmare masquerading as a scientific procedure. This is not a philosophical gap. It is a technical hole in the center of physics. The universe is constantly forcing possibilities to collapse into concrete fact. Every time light hits your retina, every time a chemical bond forms, a measurement of sorts is taking place. The most common event in the universe, a quantum system interacting with anything large enough to count as a measurement, is something the theory cannot describe. 100 years, no equation for it. We have spent a century building a sprawling trillion-dollar technological empire upon a foundation that structurally refuses to explain its most vital function. Ask yourself what kind of science that is. You build an experiment, you get a result. The mathematical framework you use to understand that result cannot tell you how the result came to exist. It gives you the probability of each possible outcome. It cannot tell you why this one and not the others. The theory can tell you that a particle has a 50% chance of being found here and a 50% chance of being found there, but it is utterly, permanently mute on the mechanism that actually makes the final choice. Ask yourself what the word understand means if it stops exactly at the moment you actually need it. We are holding a map that intricately details every single road leading up to the destination, but the destination itself is cut out of the paper, leaving nothing but a jagged, terrifying void. This structural blindness is the darkest secret of the modern scientific endeavor, and I think this is the part nobody says out loud at conferences. Not because it is a secret, because it is uncomfortable, because the theory works so well everywhere else that admitting this hole feels like it should matter more than it does. Physicists divert their eyes. They focus on the staggering precision of the probabilities, celebrating the accuracy of the predictions, while desperately ignoring the agonizing black box sitting right in the middle of the laboratory floor. They build better detectors, they write more complex algorithms, and they bury the existential dread under layers of pragmatic engineering. But the hole is there, and it has been there since the 1920s. It is a permanent, haunting reminder that reality refuses to be fully captured by human mathematics. To understand what this looks like in practice, we have to look at an experiment from 1922 that showed reality making a choice and refusing to explain itself. In 1922, two physicists named Otto Stern and Walter Gerlach fired silver atoms through a magnetic field. They were attempting to measure a property of the atoms that we now call spin, essentially how the atom behaves like a tiny, rotating magnet. What they saw should not have been possible. Classical physics said the atoms would spread out into a continuous smear. A magnetic field should deflect atoms by varying amounts depending on their orientation. Because the atoms were tumbling randomly as they exited the oven, they should have been pointing in every conceivable direction. And since orientations are continuous, pointing in any direction, the result should be a smooth gradient across the detector. Some should go high, some should go low, and the vast majority should hit everywhere in between, creating a solid, unbroken line of silver on the glass plate. That is what classical physics predicted. That is what everyone expected. It was the only outcome that made logical, biological sense to a human mind that evolved in a smooth, continuous world. Instead, the universe violently rejected human intuition. Instead, the atoms landed in two distinct spots. Two, nothing in between. The atoms were not deflected by varying amounts. They were deflected by exactly one of two fixed values. The continuous smear simply did not exist, as if reality had looked at the continuous range of possibilities and decided, no, only these two, pick one. The universe forced the silver atoms to make an absolute binary choice, up or down. There was no middle ground, no smooth gradient, no compromise. This was the experimental discovery of quantum spin, and it meant something that physicists have been living with uncomfortably ever since. Reality is not continuous. The smooth, flowing world we experience every day is a profound, macroscopic illusion. At the fundamental level, certain properties of matter do not come in smooth gradations. They come in steps, fixed values, discrete chunks. The universe is jagged. It is pixelated. And when a particle is forced to choose, it chooses instantly without intermediate states and lands exactly where the quantum rules say it should land, with exactly the probability the math predicts. The atom does not slowly rotate into the correct position. It instantaneously manifests in the allowed state the exact millisecond the magnetic field forces the measurement. The math works every time with extraordinary precision. The probabilities are absolutely flawless. But here is the question that the math does not answer. Why does the universe come in steps? What is the physical reason that a silver atom cannot have a spin pointing in any arbitrary direction? That it must choose between exactly two options and nothing else? We possess no mechanism to explain the architecture of this restriction. We can write down the rule, we can calculate the probabilities. We cannot tell you why the rule is the rule. We are blindly transcribing the laws of a universe that utterly refuses to explain its own reasoning. We are trapped in an epistemological nightmare, operating a machine we did not build and cannot comprehend. And here is what I find genuinely strange about this. We discovered that reality is quantized, that it comes in discrete chunks as a surprise. It was not predicted. It was not derived from first principles. It was found by accident when an experiment produced a result that had no business existing. We did not logically deduce the jagged nature of the cosmos. We stumbled into it in the dark and cracked our heads against its unforgiving, stair-stepped architecture. The universe handed us a fundamental fact about its own structure, and we had no framework to understand why it is true. We have spent a century layering equations over this gaping wound in our understanding, pretending that calculating the odds of an event is the exact same thing as comprehending its cause. We have been using that fact to build technology for 100 years. We still do not know why it is true. We exist in a state of terminal blindness, permanently exiled from the exact moment when the chaotic, infinite potential of the cosmos violently collapses into the cold, jagged reality we are forced to inhabit. We build machines of incomprehensible scale and complexity to interrogate the void, arrogantly expecting the universe to eventually surrender its deepest secrets to our engineering. We construct sprawling subterranean rings of supercooled magnets, accelerating subatomic particles to the absolute boundaries of the speed of light, smashing them together in the dark to forcefully crack open the underlying architecture of reality. We do this because we believe, with a desperate, almost religious fervor, that if we hit the universe hard enough, it will hand us the final puzzle pieces. This brings us to what happens when you follow that question long enough and realize that physics has not made a genuinely new fundamental discovery in over a decade. They found the last piece. The machine kept running and then nothing. We have reached the terrifying end of a profoundly comfortable road, and we are now staring into a void that refuses to give us any direction. To understand the sheer, paralyzing weight of this dead end, we must return to a moment of supposed ultimate triumph. In 2012, CERN announced the Higgs boson, the final particle predicted by the Standard Model, the one that had been missing for 50 years. The global scientific community erupted in celebration. Peter Higgs sat in the auditorium and wiped his eyes. It was supposed to be the beginning of what comes next, a door opening into new physics. The discovery was hailed as the absolute confirmation of our intellectual mastery over the subatomic world. But the door did not open. The Higgs boson was exactly where the Standard Model said it would be, exactly the mass the model predicted. No surprises, no anomalies, no cracks in the theory where something new was hiding. And that, of all things, was the problem. We had found the final brick in the wall, only to realize we were now hopelessly walled in. Because the Standard Model is not a complete theory, every physicist knows this. It leaves out gravity. It cannot explain dark matter. It has no idea why there is more matter than antimatter in the universe. It is, in the words of the people who use it daily, a placeholder, a framework that works brilliantly within its limits and collapses outside them. The Large Hadron Collider was not built merely to tie up the loose ends of an incomplete theory. The LHC was built to find what lies beyond those limits. It was designed to reach the energies where something new had to appear. Almost every theoretical prediction said so. It has been running since 2008. It found the Higgs. It found nothing else. This is where the true, suffocating dread begins to physically manifest. And here is what I keep coming back to. The silence after 2012 is more significant than the discovery that came before it. A discovery tells you where you are. Silence tells you that where you thought you were going does not exist. The most expensive scientific instrument ever built confirmed what we already knew and gave us nothing to build on. Ask yourself what that silence means for the next generation of physicists. Ask yourself what a field does when its primary tool stops producing new results. And ask yourself whether this is a temporary plateau or the first sign of something more permanent. But what if the silence is not random, but the result of a specific bet the field made and lost completely? We are not just experiencing a lull in data, we are witnessing the catastrophic collapse of an entire philosophical worldview. Imagine spending 40 years on a theory, not alone. Thousands of physicists, hundreds of thousands of papers, entire careers, graduate students trained to work inside it, and then the machine designed to confirm it runs for years and finds nothing. That is supersymmetry. And that is exactly what happened. The idea was elegant. Every particle we know has a partner, a heavier mirror version with slightly different properties. The electron has the selectron, the quark has the squark. These partners were predicted to be heavy enough that we had not seen them yet. But at the energies the LHC would reach, they had to show up. It solved three problems at once: the hierarchy problem, dark matter, the unification of forces. It was too elegant to be wrong. That is exactly what physicists said. And that is exactly what they said before the results came back empty. No superpartners at any mass, at any energy the LHC could reach. The annihilation of supersymmetry is not just a discarded hypothesis. It is the burning of the only map we had to navigate the darkest anomalies of our existence. So ask yourself what happens to a field when its dominant framework, the one that shaped careers, grants curricula, entire research programs for 4 decades, leaves no trace in the machine built to find it. Ask yourself what happens to the intuition of a generation of physicists who spent their best years looking in a direction that turned out to be empty. And ask yourself whether the problem is that supersymmetry is wrong or that we have no idea what to look at next. And I think this is the part that does not get said directly enough. When you lose your most promising direction, you do not just lose a theory, you lose the map. You are still in the same territory. You just no longer know which way is forward. There is a darker layer here. To grasp the existential dread of this loss, we must look at the specific, incomprehensible flaw in reality that supersymmetry was desperately invented to heal. Pick up a paperclip. Hold it between 2 fingers. Now take a small magnet and hold it an inch away. The paperclip moves toward the magnet. You just watched electromagnetism defeat gravity across a distance. The electromagnetic force of a magnet smaller than your thumbnail overpowered the gravitational pull of an entire planet. That gap between electromagnetism and gravity is not a small difference. It is 38 orders of magnitude. Gravity is 10 the power of 38 times weaker than electromagnetism. Written out, that number has 38 zeros after the 1. It is by any measure the most extreme disproportion between 2 fundamental forces in nature, and physics has no explanation for why. This is called the hierarchy problem. It is not a new puzzle. It has been sitting at the center of theoretical physics since the 1970s. The Standard Model contains no mechanism that would naturally produce such an enormous gap. In fact, when you calculate corrections to the Higgs mass using quantum field theory, you get contributions that should push the mass up to the highest energy scales in physics, far larger than what is observed. To get the Higgs mass we actually measure, those contributions have to cancel each other with a precision of 1 part in 10 to the 34th, 34 decimal places of accidental cancellation. That is not a coincidence. Coincidences at that scale do not exist. What this means is that the Standard Model as it stands requires a kind of fine-tuning that no known physical principle can account for. The numbers work only if they are set with extraordinary precision by something the theory does not contain. Supersymmetry was supposed to solve this. Its mathematical structure would have made the cancellation natural rather than accidental. It was the elegant, beautiful shield protecting us from the horrifying thought that our universe is simply a precarious, impossible accident. But the machine ran, the shield shattered, and the void stared back. Without it, the problem remains completely open. Ask yourself what it means for a theory to require its own numbers to be set by hand to 34 decimal places. And then ask yourself how much you trust a foundation that is built on an accident that large. And here is what I keep returning to. The hierarchy problem is not discussed much outside physics. It does not make headlines, but it means that the theory governing every particle interaction ever measured contains at its core a number that has no explanation. We are not missing a detail. We are missing something structural. We are entirely, terrifyingly blind, wandering through a fine-tuned cosmos with a burnt map and no possible understanding of the unyielding dark that surrounds us. We walk through the world possessing a deeply comforting, fiercely protected psychological illusion that we inhabit a singular, coherent, and logically unified physical reality. We assume, with almost arrogant certainty, that the laws governing the slow, majestic orbit of a distant planet are woven from the exact same mathematical fabric as the microscopic dance of a subatomic particle. We demand structural coherence from the cosmos, believing that our scientific progress is an unyielding march toward one beautiful, overarching master equation. But what if the two theories that were supposed to describe all of this cannot coexist in the same equation without destroying each other? The terrifying truth, hidden beneath the glittering facade of modern technology, is that there are two rulebooks for reality. One describes everything large, planets, galaxies, the shape of space itself. The other describes everything small, atoms, particles, the behavior of energy at its most fundamental. Both rulebooks are right. Both have been tested more thoroughly than any other ideas in science, and they cannot both be true at the same time. The mutual hostility between these two frameworks fundamentally shatters our intuitive understanding of existence. General relativity says space is smooth. It bends, it stretches, it curves around mass like a rubber sheet under a heavy ball. The geometry is continuous. There are no gaps, no jumps, no minimum unit of distance. Quantum mechanics says the opposite. At the smallest scales, everything is granular. Energy comes in packets. Probabilities replace certainties. Fields fluctuate randomly, even in empty space. These are not just different descriptions. They are contradictory assumptions about what reality is made of. You cannot simultaneously inhabit a universe that is a seamless, infinitely divisible sheet of silk, and a universe that is a chaotic, pixelated storm of jagged, discrete probabilities. Yet, we survive by practicing a sophisticated, willful blindness. For most situations, this does not matter. General relativity handles the large, quantum mechanics handles the small. They operate in separate domains, and the contradiction stays quiet. But avoidance is not understanding. We have built the entirety of modern physics on two frameworks that are individually perfect and mutually incompatible. Every physicist knows this. It is not a secret. It is the central unsolved problem of the field. We have known about the incompatibility for nearly a century. We have learned to work around it, to use one theory here and the other there, and to avoid the places where they collide. The existential horror manifests when avoidance becomes physically impossible. There are places where both are needed simultaneously. At the center of every black hole, and at the first instant of the Big Bang, the two best theories in physics are required simultaneously. General relativity, which describes gravity, space, and time, and quantum mechanics, which describes everything else at the smallest scales. Both theories are needed. Both theories work with extraordinary precision in their own domains. And when you try to apply them together, the mathematics produces nonsense. Not approximate nonsense, not results that are slightly off. Division by zero, infinite values, with no physical meaning. The calculation breaks down completely. In those places, the math stops working entirely, not approximately, not with small errors. It produces infinities, division by zero, numbers that mean nothing. This catastrophic failure represents the absolute boundary of human reason. This is not a technical problem waiting for a better computer. It is a structural incompatibility. General relativity treats space and time as a smooth, continuous fabric that bends in the presence of mass. Quantum mechanics treats the world as fundamentally discrete, and probabilistic, with fields that fluctuate randomly even in empty space. These two pictures of reality are not just different, they make contradictory assumptions about the nature of space itself. So ask yourself what it means that our two most successful theories tested to extraordinary precision used to build GPS satellites and MRI machines and particle accelerators cannot exist in the same equation without producing gibberish. We have successfully hacked the superficial layers of reality, but the foundational code is tearing itself apart. To understand what happens when you cannot avoid it anymore, we have to look at the specific place where the collision becomes impossible to ignore. In 2012, a physicist named Joseph Polchinski sat down with two colleagues and worked through the mathematics of what happens at the edge of a black hole. They were not expecting what they found. What the math produced was so uncomfortable that when they published it, the physics community spent years trying to find a mistake. Nobody found one. The problem starts with the event horizon, the boundary around a black hole beyond which nothing can escape. General relativity says crossing an event horizon should feel like nothing. No sudden wall, no dramatic moment. You would fall through it without noticing, at least for a while. The horizon's invisible. It is a point of no return defined by geometry, not by any physical structure. But the merciless rules of the subatomic realm violently disagree. Polchinski's calculations said otherwise. When you apply the rules of quantum mechanics to the event horizon, specifically the rule that quantum information cannot be destroyed, the math produces a wall of intense radiation right at the boundary, not inside, right at the edge. An observer falling in would not drift through gently. They would hit something. This is called the firewall paradox. And here is why it matters beyond black holes. The firewall is not a prediction that can be tested. We cannot send observers into black holes and ask what they experienced. It is a logical consequence. If quantum mechanics is right, and if general relativity is right, and if information is preserved, then a firewall must exist. But if a firewall exists, then general relativity is wrong about what crossing a horizon feels like. Three assumptions, all considered solid. Together, they produce a contradiction. We are left staring at the wreckage of our most trusted frameworks. What does it mean when your best theories corner each other like this? One of them has to bend. We do not know which one. And I think this is the honest picture of where theoretical physics stands right now. Not at the edge of completion, but at a three-way contradiction with no clear exit. One of two things must be true. Either general relativity is not quite right at the smaller scales, or quantum mechanics is not quite right at the larger scales, or both are approximations of a deeper theory that we do not have yet. Every approach to quantum gravity, string theory, loop quantum gravity, causal dynamical triangulations is an attempt to find that deeper theory. None of them has made a confirmed experimental prediction. The dread of this situation is not in the mystery itself, but in the agonizing clarity with which we view our own doom. And here is what I find most striking about this situation. We know exactly where the problem is. We know the precise conditions under which our two best theories fail. The center of a black hole, the first fraction of a second after the Big Bang. These are not vague unknowns. They are specific locations where the known laws of physics stop working. We have circled them on the map. We just cannot go there. And we cannot build a theory that describes what happens there without the math collapsing. What does it mean to know exactly where your understanding ends and have no clear path to what lies beyond it? So ask yourself what kind of foundation that is. We are passengers on a fragile vessel, confidently sailing the cosmic ocean, using two completely different maps that actively deny each other's physical existence, desperately hoping we never reach the coordinates where the mutually assured destruction of our physics becomes our absolute, unyielding reality. Space, distance, separation. These are the absolute, foundational pillars upon which human sanity is constructed. We biologically rely on the deeply comforting assumption that if two objects are physically separated by miles, continents, or the vast, freezing gulfs of interstellar space, they are fundamentally isolated from one another. We believe in the protective armor of distance. If a catastrophic event occurs on the other side of the planet, we feel safe because the physical space between us acts as an impenetrable barrier. In classical physics, this intuitive, deeply ingrained concept is known as local reality. It dictates that an object is only influenced by its immediate surroundings, and that no signal, no force, and no information can ever travel faster than the absolute cosmic speed limit of light. Local reality is what prevents the universe from collapsing into a chaotic, incomprehensible nightmare of instantaneous cause and effect. It is the boundary that defines what it means to exist as an individual, separate entity in the cosmos. But the brutal, uncompromising reality of modern physics is that this fundamental pillar of human understanding is a complete and utter hallucination. To understand the sheer, paralyzing horror of this revelation, we must trace the origin of this nightmare back to the greatest, most fiercely defensive mind of the 20th century. Einstein did not like quantum mechanics. He used it. He understood it better than almost anyone, but he did not believe it was the final word on reality. He looked directly at the mathematics describing the subatomic realm and recoiled in absolute, visceral disgust at what it implied about the physical world. In 1935, he published a paper with two colleagues, Boris Podolsky and Nathan Rosen, that he thought would demonstrate quantum mechanics was incomplete. The paper described a situation so strange that surely he argued something was missing from the theory. The terrifying scenario Einstein constructed to destroy quantum mechanics goes like this. The setup is this: two particles interact and then fly apart in opposite directions. Imagine them traveling into the deepest void, separated by millions of light years of freezing, empty vacuum. Quantum mechanics says that certain properties of these particles, like their spin, remain connected even after separation. Measure one particle, and you instantly know something about the other, no matter how far away it is. Einstein famously and mockingly labeled this deeply unsettling phenomenon. Einstein called this spooky action at a distance and said it was absurd. His entire worldview was built on the unyielding mathematics of relativity, which strictly forbids anything from traveling faster than light. If measuring one particle instantly affects another particle on the other side of the room or the other side of the galaxy, then information is traveling faster than light, and nothing travels faster than light. To accept this premise would mean accepting that the universe is fundamentally geometrically broken. Therefore, Einstein concluded quantum mechanics must be incomplete. He desperately proposed a deeply satisfying, clean, and incredibly sensible alternative that perfectly protected human intuition. There must be hidden variables, additional information carried by the particles that determines the outcome of measurements in advance without any need for instant connection across space. It was exactly like taking a pair of matching gloves, placing them in two separate boxes, and shipping them to opposite ends of the world. Opening one box and finding a left glove instantly tells you the other box contains the right glove, entirely without any spooky, faster-than-light communication. It was a clean argument. It felt airtight. For decades, this profound debate about the fundamental architecture of reality sat unanswered, a lingering philosophical ghost, because nobody could figure out how to physically build an experiment capable of testing whether distant objects were genuinely connected or only appearing to be. Ask yourself which is more disturbing, that Einstein was wrong or what being wrong actually implied. Because the experiment he designed to show quantum mechanics was incomplete ended up doing the opposite, the mathematics of his argument was eventually turned into a testable prediction. But what if the problem is not just the connection between particles, but what that connection reveals about whether reality exists at all before we look at it? In 1964, a physicist named John Bell did something quietly devastating. He took Einstein's argument about hidden variables and turned it into mathematics. He mathematically found the exact boundary line between Einstein's comforting reality and the terrifying quantum void. He derived an inequality, a precise numerical limit that any theory with hidden variables must satisfy. If the world works the way Einstein thought it did, with particles carrying predetermined answers to measurement questions, experiments would produce results within Bell's limit. If quantum mechanics was right, and the connection between particles was genuinely instantaneous and non-local, experiments would violate it. The blueprint to test the very fabric of existence had finally been drafted. The experiments were run. The limit was violated. Alan Aspect and his team confirmed this in 1982 with precision that left no room for alternative explanations. When the results finally came back, they were completely, devastatingly unambiguous. The result has been confirmed hundreds of times since, with increasingly careful controls closing every possible loophole. The most recent loophole-free tests were completed in 2015. The answer has not changed. And when it was tested, quantum mechanics won. The 2022 Nobel Prize in Physics was awarded specifically for this work to Aspect, John Clauser, and Anton Zeilinger. Einstein spent the last 20 years of his life convinced quantum mechanics was missing something. The missing something turned out to be in his own assumptions about how reality works. The comforting theory of hidden gloves in boxes was mathematically eradicated. The hidden variables do not exist. The instant connection is real. Reality is non-local. Two particles that have interacted remain connected across any distance. Measuring one instantly determines something about the other. This is not a metaphor. It is not an approximation. It is a measured, reproducible, experimentally confirmed property of the universe we live in. We must violently confront the agonizing philosophical fallout of this physical truth. And here is what this actually means stated plainly. Einstein's picture of reality, where objects have definite properties independent of measurement, and where nothing influences anything else faster than light, is wrong, not approximately wrong, ruled out by experiment. What does it mean that the most intuitive picture of reality, the one where things exist and have properties, whether or not you look at them, has been experimentally eliminated? Most people walk through their lives with Einstein's picture of reality in their heads. Solid objects with definite properties connected to other objects only through forces that travel at finite speed. We desperately cling to this illusion because it is the only way our fragile, biological minds can process existence without collapsing into panic. That picture is wrong. The universe does not work that way. And I think the fact that this is not the first thing we tell people about physics says something about how uncomfortable the truth actually is. The universe is a tightly woven, instantly responsive web of absolute, simultaneous connection, a sprawling geometry where the concept of being alone or isolated simply ceases to exist at the fundamental layer. Spooky action at a distance turned out to be an accurate description. The instant correlation is real, but it does not allow you to send a message faster than light. The outcome of each measurement is random, and you cannot control what result you get. So the theory does not violate relativity in a way that allows faster than light communication. But it does mean that two particles separated by any distance are not fully independent systems. They share a state. What happens to one is instantaneously correlated with what happens to the other. They are, in a profoundly terrifying, physically meaningful sense, the exact same thing operating in two places at once. What does it mean for our picture of space that two objects on opposite sides of the universe can be connected in a way that ignores the distance between them? We look at the seemingly vast, empty voids between the stars and intuitively assume they are filled with nothing but distance and time. But space, in the quantum mechanical picture, does not separate things the way we assume it does. The distance between two entangled particles is in some sense irrelevant to their physical relationship. And if distance can be irrelevant, what exactly is space doing? If the invisible, underlying architecture of the universe ignores physical separation entirely, it implies that the three-dimensional space we move through, the depth we perceive, and the distances we travel are nothing more than a derived, macroscopic projection. We are living inside a reality that actively mocks our biological intuition, wandering blindly through a cosmos where separation is a lie and everything is fundamentally entangled in the dark. Most physicists will tell you entanglement is well understood mathematically, and I think that is true. What is not understood is what it means for the nature of space and locality, and whether the smooth, continuous space of general relativity can survive contact with a quantum reality where distance sometimes means nothing at all. We are forced to ask ourselves whether the universe we thought we inhabited, a universe defined by the protective armor of distance and the rational flow of cause and effect, has ever actually existed, or if we have merely been hallucinating a comfortable physical stage upon a dark, unfathomably connected quantum abyss. Time is the most immediate feature of experience, the one thing that seems impossible to argue away. We construct our entire conscious existence around the unyielding forward march of the clock. We relentlessly categorize our lives into the immutable past, the fleeting present, and the undetermined future. We biologically feel the flow of seconds slipping through our grasp, carrying us helplessly from birth toward inevitable decay. We assume that this flow is a universal constant, a fundamental, mechanical ticking woven into the very fabric of the cosmos, dictating the progression of stars and the lives of human beings with equal, unforgiving absolute authority. But what if this unbroken flow is the most elaborate, agonizing hallucination humanity has ever suffered? What if the past is not fixed, the future is not waiting, and the present moment you are experiencing right now is nothing more than a localized, thermodynamic accident? To unravel the terrifying illusion of time, we must first look at how the universe actively rewrites its own history when forced under the unforgiving lens of quantum mechanics. Fire a single electron at a barrier with two slits cut into it. Behind the barrier, place a detector screen. If the electron is a particle, a tiny ball, it should go through one slit or the other and leave a single mark on the screen. If you fire many electrons, you should get two clusters of marks, one behind each slit. What you get instead is an interference pattern. alternating bands of many marks and no marks spread across the screen, the pattern that light makes when two waves overlap and either reinforce or cancel each other. The electron fired alone went through both slits simultaneously. It interfered with itself. It behaved as a wave. Now put a detector at one of the slits to find out which one the electron actually went through. The interference pattern disappears. The moment you measure which path the electron took, it stops taking both paths. The wave collapses. You get two clusters of marks, particle behavior. The act of looking changed what happened. This is deeply unsettling, but it is merely the prologue to the true existential nightmare. John Wheeler was one of the physicists who gave black holes their name. He was also responsible for one of the most disorienting thought experiments in the history of physics, and then for watching it become a real experiment that confirmed his intuition. Wheeler proposed this. Take the double-slit setup, but add a twist. Do not decide whether to measure which slit the electron went through until after the electron has already passed the barrier. Make the choice, observe or not observe, at the last possible moment after the electron is already in flight past the slits. Classical intuition says this should not matter. The electron already went through one slit or both. Whatever happened, happened. Your decision now cannot reach back and change it. But quantum mechanics says otherwise. And when the experiment was actually run using light rather than electrons, with the decision made by a random number generator after the photon had passed the barrier, the result matched quantum mechanics. Choosing to measure which path was taken after the photon had already traveled through the apparatus changed the pattern on the screen retroactively. The past behavior of the photon depended on a decision made in its future. We must pause and violently confront what this physical result demands of our sanity. What does that mean for what the word past actually describes? In quantum mechanics, the past is not fully determined until information about it becomes fixed in the present. The photon did not have a definite path through the slits until the decision about whether to look was made, even if that decision came later. Ask yourself how much of the universe's history is genuinely settled, and ask yourself what it means that the answer might be less than you think. This is not philosophy. This is what the experiment shows. The past is not fully real until the present locks it in. History is not a rigid foundation upon which the present rests. It is a fluid, undefined vapor that only solidifies when we forcefully interrogate it. This brings us to something even more fundamental: the question of whether the framework we use to describe quantum reality contains time at all. If you write down the equation that is supposed to describe the quantum state of the entire universe, combining quantum mechanics with general relativity in the most straightforward way physicists know how, something strange happens. The equation works, but time disappears from it. This equation is called the Wheeler-DeWitt equation. It was developed in the 1960s by John Wheeler and Bryce DeWitt as one of the first serious attempts to write down quantum gravity, and it has a feature that has bothered physicists ever since. The wave function of the universe that the equation describes does not evolve. There is no time variable. The equation is static. The universe, according to this mathematics, does not change. But the universe does change. You're reading this. Things happen. Sequences of events occur in a definite order. And yet the equation that is supposed to describe reality at its most fundamental level does not contain it. So where does time come from? One answer developed by physicists Don Page and William Wouters in the 1980s is that time emerges from entanglement. From the perspective of the universe as a whole, nothing changes. But inside the universe, subsystems become entangled with each other, and from the perspective of one subsystem looking at another, change appears. Time is not a feature of reality at the fundamental level. It is what entanglement looks like from the inside. Ask yourself what it means to be inside a process that produces the experience of time without time being a fundamental ingredient. Ask yourself what it means that the most basic feature of your experience, the fact that one moment follows another, may not be written into the deepest laws of physics, and ask yourself whether a universe described by a timeless equation is the kind of universe you thought you were living in. To understand why, we have to look at the physicist who spent his life on this question and what the effort cost him. Ludwig Boltzmann was one of the greatest physicists of the 19th century. He built the mathematical foundation connecting the behavior of individual atoms to the large-scale properties of heat and gas. The laws of physics are symmetric in time. Run any fundamental physical interaction backward, and you get an interaction that is equally valid. A ball bouncing off a wall runs the same way in either direction. Two particles colliding and exchanging energy look the same forward and backward. At the level of fundamental physics, past and future are interchangeable, but in practice, time has a direction. Heat flows from hot objects to cold ones, never the reverse. Broken glasses do not reassemble. Eggs do not unscramble. The past is different from the future in every observable way. This is the second law of thermodynamics. Entropy, the measure of disorder, always increases. Time runs in the direction of increasing entropy. Boltzmann understood this statistically. But what if time is not just directionless at the fundamental level, but altogether absent? An illusion generated by something deeper. Carlo Ralli is one of the most serious physicists working on quantum gravity today. He is also the person who has most directly argued in technical papers and in public that time as we experience it does not exist at the fundamental level of reality. Not that time is weird, not that time is relative, that the flow of time, the sense of a present moment moving from past to future, is generated by our particular position inside a physical process, and that the universe itself has no such arrow built into it. The argument builds on three pieces. First, the Wheeler-Ditt equation. The universe's wave function is timeless. Second, Boltzmann's statistical mechanics. The direction of time is a thermodynamic effect of entropy increasing. Third, thermal time. The sense of time flowing is generated by the way a warm system, like a human brain, interacts with its environment. We are not observers of time, we are products of entropy. Think about what that means practically. The feeling that now is special, that this moment exists and others do not, is in Rell's framework a feature of being a warm entangled system embedded in an environment. From outside the system there is no now. There is a static structure in which all moments exist equally, and the experience of moving through them is generated by the entanglement between the observer and the world. This is not mysticism. Rell is doing physics. The framework produces mathematical predictions, and it fits with what the Wheeler-Ditt equation already suggests, that time is not a fundamental ingredient of reality, but something that emerges from it. So ask yourself what you are. If the experience of moving through time is a thermal effect generated by your own entropy, we are trapped in a frozen block of geometry, desperately hallucinating a sense of forward motion simply because our biological bodies are slowly decaying into disorder. Ask yourself what the word now means. If no moment is more real than any other, and ask yourself whether a universe without a fundamental present is the universe you have been living in all along. and you simply never had a way to see it. We are blind to the agonizing truth that time does not pass. We merely endure the static illusion of our own unraveling entropy. We possess a deeply ingrained, almost desperate psychological need to believe in the permanence of the physical world, assuming that even if an object is burned to ash or ground into dust, its fundamental essence, the microscopic record of its existence, remains permanently etched into the indestructible fabric of the cosmos. In the realm of theoretical physics, this intuitive comfort is mathematically formalized by a concept that governs the entirety of the subatomic world. Quantum mechanics has a rule, one of its deepest rules, that information cannot be destroyed. Every physical process is in principle reversible. If you know the final state of a system with perfect precision, you can calculate its initial state. This absolute, unyielding guarantee of cosmic memory is the foundational bedrock upon which our understanding of reality rests. This is called unitarity, and it is not optional. It is baked into the mathematical structure of quantum mechanics at a fundamental level. Unitarity dictates that the universe does not forget, it merely scatters its data. But this profound mathematical assurance collided violently with the darkest, most terrifying gravitational anomalies in the cosmos, sparking an intellectual war that threatened to completely dismantle the foundation of modern science. Two of the most brilliant physicists of the last half-century spent 30 years arguing about what happens to information when it falls into a black hole. The existential crisis that brought physics to its knees did not emerge from a telescope, but from a devastating theoretical realization. The problem begins with Stephen Hawking's 1974 discovery that black holes are not entirely black. Before this moment, the event horizon was viewed as a permanent cosmic vault, a one-way threshold where matter and light vanished forever but remained safely locked inside the singularity. However, the unforgiving mathematics of the quantum realm dictated a much darker reality. Quantum effects near the event horizon, the boundary beyond which nothing can escape, cause black holes to slowly radiate energy and particles. This microscopic, relentless leakage completely changes the ultimate fate of the anomaly. This radiation, now called Hawking radiation, is thermal. It is random. It carries no information about what fell in. And because the black hole is losing energy through this radiation, it eventually evaporates completely. It is precisely here, in the final dying gasp of a black hole, that the absolute horror of the paradox physically manifests. If the black hole simply vanishes into a mist of chaotic, meaningless radiation, we are forced to ask what happened to the complex quantum data of the objects it consumed over billions of years. But if a black hole evaporates, and the radiation carries no information about what fell in, then information has been destroyed. This is not merely a theoretical inconvenience. It is a catastrophic violation of the ultimate law of existence. A star, a planet, a library, everything that ever crossed the event horizon is gone. Not just physically crushed, but mathematically erased from the timeline of the universe. Not just inaccessible, gone. Unitarity is violated. The scientific community found itself paralyzed by an impossible contradiction. General relativity explicitly demanded that the black hole must evaporate, while quantum mechanics strictly forbade the deletion of the information trapped inside it. So ask yourself, which gives way, the structure of quantum mechanics or the structure of general relativity? The two absolute pillars of human understanding were locked in a mutually assured destruction, and the greatest minds on Earth were forced to choose a side. Hawking said information was genuinely lost. He was willing to accept that the universe contains permanent, irreversible blind spots where the fundamental laws of physics go to die. Leonard Susskind, horrified by the prospect of a universe that actively deletes its own history, violently disagreed. Susskind said it could not be. Unitarity was inviolable, and the information had to escape somehow encoded in the Hawking radiation in a form too subtle to see directly. This was not a polite academic disagreement. It was a desperate battle for the epistemological survival of science itself. They argued publicly for 3 decades. The entire physics community was dragged into this suffocating conceptual abyss, struggling to map a reality that seemed determined to hide its deepest mechanisms. The argument was not resolved. It was declared over when one side changed its mind. In 2004, Hawking conceded. He stood before his colleagues and admitted that the irreversible destruction of information was simply too heavy a price for theoretical physics to bear. He said he had been wrong and information was preserved, but his surrender offered absolutely no comfort, because the underlying nightmare remained entirely unexplained. He did not provide a complete mechanism for how. The terrifying reality of this concession is that we are still wandering blindly in the dark. The argument ended, but the problem did not. We do not have a complete description of how information escapes a black hole. We simply decided, out of pure mathematical desperation, that it absolutely must escape, because the alternative is a universe that fundamentally makes no sense. We have arguments that it must be based on unitarity, and we have the mathematics of the holographic principle pointing in a direction. But the actual mechanism, the physical story of how every piece of information that ever crossed an event horizon gets encoded in outgoing radiation, remains an open question 30 years. In the desperate, agonizing search to resolve this paradox, theoretical physics stumbled into a mathematical framework so profoundly disturbing that it completely shatters our fundamental perception of reality. In 1997, Juan Maldacena published a paper that is now the most cited in the history of theoretical physics. He did not build a new particle accelerator, and he did not discover a new fundamental force. He built a mathematical bridge between 2 entirely different, seemingly incompatible models of the cosmos. What it showed was that 2 completely different theories, one with gravity, one without, one in 5 dimensions, one in 4, are mathematically identical. This was not an approximation or a clever analogy. Every calculation in one maps perfectly onto a calculation in the other. They are the same theory written in 2 different languages. The sheer suffocating dread of Maldacena's discovery lies in what it dictates about the physical space we believe we occupy. The implication is something that sounds wrong the first time you hear it. It assaults our most basic biological intuition about existence. The 3-dimensional interior of a space, everything inside it, every particle, every force, gravity itself, can be completely described by a theory living on its 2-dimensional surface, like a hologram, a flat film that contains all the information needed to reconstruct a 3-dimensional image. This is not a science fiction trope, nor is it a philosophical metaphor intended to make us feel small. It is a rigid, unyielding, mathematical duality. The universe might work exactly like that. We are forced to violently reevaluate the nature of our immediate surroundings. Think about what that means for the room you're sitting in right now. You look around and you perceive volume, you perceive distance. You experience the physical sensation of moving through a deep, expansive 3-dimensional environment. You believe that the air in your lungs and the solid walls surrounding you are foundational, primary aspects of the cosmos. But the math suggests a terrifyingly deceptive architecture. The depth of it, the distance from where you are to the wall across from you, might not be fundamental. It might be a property that emerges from information encoded on a surface you cannot see in fewer dimensions than you experience. The third dimension might be something the universe generates, not something the universe is made of. If this principle holds true, it means that the entirety of human existence, the birth and death of stars, the sprawling complexity of our galaxies, and the intricate biological machinery of your own body are nothing more than a derived projection. We are a holographic shadow cast by a lower dimensional reality that sits on the inaccessible boundary of the cosmos. Ask yourself how you would know the difference. If your brain is merely a three-dimensional rendering of flat, two-dimensional quantum data, every physical sensation, every measurement you take, and every step you walk is perfectly encoded to uphold the illusion of depth. You are physically incapable of stepping outside the projection to observe the projector. Ask yourself what the word real means. If the dimension you move through every day is emergent rather than fundamental, we are forced to consider that we are the geometric equivalent of a mirage, hovering over a desolate, flat plane of pure mathematics, convinced of our own volume only because the code demands it. And ask yourself whether a physics that arrives at this conclusion by following the mathematics of black holes, not by looking for it, is telling us something about reality or something about mathematics. We did not actively seek out this holographic nightmare. We were forcefully driven into it by the uncompromising logic of our own equations, desperately trying to prevent the universe from illegally deleting its own information. Most physicists say it is just a powerful calculational tool. They use it to solve impossible equations by translating them into a flatter, simpler dimension, and then translating the answers back, treating the bizarre geometry as nothing more than a convenient mathematical fiction. But this defensive dismissal rings incredibly hollow. I do not know what just means when the tool is exact, complete, and describes everything we observe. At some point, just math and reality become the same thing, and I think we pass that point without noticing. We are hopelessly trapped inside an information graveyard, existing as complex mathematical ghosts haunting a three-dimensional illusion, forever blind to the flat, unfeeling surface where the true reality of our universe is actually written in the dark. We have driven the entire enterprise of human science toward one singular, desperate psychological goal. We want to find the absolute bottom. We want to dig through the superficial layers of biology, chemistry, and macroscopic physics, past the chaotic swarm of molecules and atoms, past the ghostly fluctuations of subatomic particles and the vibrating fields of quantum mechanics, until our shovels finally strike a solid, unyielding bedrock. We possess a profound biological need for a foundation. We believe that if we push our mathematics far enough, we will eventually uncover a single, elegant master equation, a definitive set of rules that logically proves why the universe must be exactly the way we observe it, and why no other physical reality is mathematically permitted to exist. We want to believe that our specific cosmos, with its delicate balance of forces, its precise masses of elementary particles, and its specific number of spatial dimensions, is the necessary, inevitable consequence of absolute logic. But the final, most terrifying revelation of modern theoretical physics is that this foundational bedrock simply does not exist. When we finally pushed our most advanced mathematical frameworks to the absolute limit, the floor completely gave way beneath us. We did not find a singular, elegant answer to existence. We found an infinite, inescapable trap. To understand the catastrophic collapse of this scientific dream, we must look at what happens when we combine our two most sophisticated, leading theories regarding the ultimate nature of the cosmos. The first is cosmic inflation, the highly successful theory describing the violent, exponential expansion of the universe in the first microscopic fraction of a second after its birth. The mathematics of inflation strongly suggests that this expansion did not just happen once, in one place. It dictates a process of eternal inflation, where the rapid expansion stops in certain localized pockets, creating stable bubble universes like our own, while the space between them continues to violently inflate forever, endlessly spawning an infinite number of other, disconnected bubble universes. The second theory is string theory, humanity's most mathematically rigorous attempt to unify the contradictory laws of quantum mechanics and general relativity into a single framework. String theory requires the universe to have extra spatial dimensions, microscopic dimensions curled up and folded in upon themselves in unbelievably complex geometric shapes. The specific shape of these hidden dimensions dictates the physical properties of the universe, determining the exact mass of an electron, the strength of gravity, and the nature of dark energy. For decades, physicists believed that the mathematics of string theory would eventually identify one single, unique geometric shape for these hidden dimensions, perfectly predicting the exact physical properties of our specific universe. They thought the math would prove that our reality was the only mathematically stable option, but the mathematics refused to cooperate. As the equations became more refined, physicists realized that string theory does not produce one unique solution. It produces an incomprehensible apocalypse of possibilities. The mathematics allows for the hidden dimensions to be folded in approximately 10 to the power of 500 different ways. 10 to the power of 500. That is a 1 followed by 500 zeros. To even attempt to comprehend the paralyzing scale of this number, you must realize that there are only about 10 to the power of 80 atoms in the entire observable universe. If you were to take every single atom in every star, every planet, and every galaxy we can see, and replace each individual atom with another entire universe, you would not even microscopically begin to approach the number of universes that string theory allows. When you combine this staggering landscape of possibilities with the eternal, bubbling expansion of cosmic inflation, the logical conclusion is an existential nightmare. The mathematics dictates that every single one of those 10 to the power of 500 possible universes is actually physically realized somewhere in the sprawling infinite multiverse. Every possible variation of physical law, every conceivable tuning of gravity, every imaginable combination of matter and energy exists out there in the dark. And this is where the traditional, comforting framework of the scientific method violently dies. A theory that predicts 10 to the power of 500 possible universes predicts absolutely nothing specific about our own. It is the ultimate, catastrophic defeat of prediction. If the mathematics says that literally everything is possible somewhere, then asking the question of why our specific universe operates the way it does loses all physical meaning. Why is gravity exactly this strong? Why is the electron exactly this heavy? The answer is no longer a profound, elegant law of nature. The answer is simply a statistical accident. We live in this specific universe merely because it happens to be one of the rare combinations of physical laws that allows carbon-based biological life to evolve. Look up at the stars and ask the question, If the laws were even slightly different, we would not exist to observe them. This is known as the anthropic principle, and to many physicists, it is not a scientific explanation. It is a total intellectual surrender. It means we have successfully mapped the precise limits of human knowledge, only to discover that the fundamental reason for our existence is nothing more than a random roll of hyperdimensional dice in a casino of infinite proportions. But the dread of this infinite multiverse leads us directly into a much darker, fundamentally more terrifying philosophical corner. If there is an infinite multiverse containing every possible mathematical variation of reality, we are forced to ask a deeply unsettling question about the nature of the physical stuff that makes up these universes. We traditionally assume that mathematics is merely a tool, an abstract language invented by human minds to describe the behavior of tangible physical matter. We believe that a rock, a star, or a human brain is made of real, physical substance, and the math simply dictates how that substance moves. But as physics has dug deeper into the subatomic realm, the concept of physical substance has completely evaporated. An electron is not a tiny, solid sphere. It is a bundle of mathematical properties, a collection of numbers representing mass, spin, and charge, interacting according to strict mathematical rules. When you strip away the macroscopic illusion of solidity, there is absolutely no physical stuff left. There is only the math. This unavoidable realization led the physicist Max Tegmark to propose a concept that fundamentally shatters our entire perception of existence. It is called the mathematical universe hypothesis. Tegmark argues that if the universe is perfectly described by mathematics at every single observable level, and if there is no underlying physical substance holding it together, then we must accept the agonizing, literal truth of our situation. The universe is not simply described by mathematics. The universe is mathematics. Physical reality does not exist. The cosmos is nothing more than a pure, unfeeling mathematical structure, a vast web of logical relations and equations floating in a conceptual void. This hypothesis completely redefines the horror of the multiverse. In Tegmark's framework, every single mathematical structure that can exist logically does exist physically, because physical existence and mathematical existence are the exact same thing. We are not biological creatures made of tangible matter living inside a physical container. We are incredibly complex, self-aware equations hallucinating the experience of physical solidity. We are a localized processing of information, a pattern of mathematical logic that has evolved to perceive itself as a living being, embedded within a larger mathematical structure that we interpret as space and time. This is the ultimate, inescapable trap. We spent thousands of years meticulously studying the physical world, desperately hoping to find a profound, spiritual meaning or a definitive, physical foundation to our existence. We built towering particle accelerators, launched telescopes into the freezing void, and covered endless blackboards with equations, all in the desperate pursuit of reality. And the universe rewarded our relentless curiosity by proving that reality itself is an illusion. The bottom layer of existence is not a physical foundation. It is a bottomless, infinite descent into pure abstraction. We have successfully eradicated the physical world. We are forced to violently confront the paralyzing truth of our own artificiality. We are trapped inside an infinite mathematical structure, or perhaps an unfathomably vast simulation running on an architecture we cannot even begin to comprehend. And the most terrifying part of this trap is that there is absolutely no escape. You cannot break out of the universe because there is no outside to mathematics. There is no physical boundary to cross, no physical door to open, and no underlying physical reality to wake up into. We are permanently, eternally imprisoned within the unforgiving logic of the equations. We have reached the absolute boundary of what science can tell us about our world, and the final answer is a cold, silent void. The physics ends here, not with a triumphant mastery over nature, but with the chilling realization that nature was merely a mathematical projection all along. We are blind to the 17 layers of reality because the reality we were looking for was never there. The cosmos is an unyielding, infinite algorithm, and we are nothing more than a fleeting string of code, briefly observing its own execution in the dark. Good night, and I will see you in the next video.